and welcome everyone. My name is Jan Kopřiva and today we're going to take a look at a sample solution for one of the final challenges of the European Cybersecurity Competition 2021. European Cybersecurity Competition, or ECSC, as the name suggests, it's a competition aimed towards young people, university students and high school students who are interested in cybersecurity. I was an author of one of the challenges that the students or that the participants had to solve last year because ECSC 2021 was held here in the Czech Republic, and I was asked by the event organizers to prepare a video write-up, as it were. So without further ado, let's jump right in and take a look at what challenge did the participants have to solve last year. The participants were provided with two files, objectives.docx and a zip file. So let's take a look what the doc file actually contains. It tells us that we are a security analyst working for a company called Supercorp Zero, which in stark contrast to its name is only a small Czech company making erasers. Since we are a security analyst anyway, a colleague of ours from a financial department of the company sent us an EML file with an email that appears to contain an invoice from our longtime supplier. But the email seems, as our colleague put it, somewhat suspicious. So let's take a look at what we have here. Our colleague encrypted the file in the zip with the password infected. So the first thing we have to do is actually extract the file. And let's take a look at what we have here. Alright, we can clearly see why our colleague thought that this email looked suspicious. Even if we leave alone the email address of the supposed sender, the entire contents of the email doesn't look too trustworthy. Please ensure that the attached invoice provided by us, i.e. your completely trusted supplier of many years, is paid in full ASAP. The password is here. And don't worry that we never communicate in English. We have done so now. So, alright, no one would fall for a scam such as this one, or rather, not many people would have. But this is the challenge we have in front of us. Let's take a look at what we should actually find out. So for the EML itself, we have two main points we should solve. First one, what appears to be the domain of the mail server used to send the message. And then we are supposed to answer what was the original extension of the attached file. So let's start by discovering the domain name of the mail server. In case of EMLs, it's actually quite easy to display all the email headers because EML is a plain text file, so we can just open it in our notepad, in this case Notepad++, and then we see all of the headers in front of us. We could, of course, look at the headers in Outlook as well. Let me just show you how one might do that. Here, next to the tags, we have this arrow. If we click on it here, we have all the email headers. They are, as we can see, they are completely the same, so it doesn't matter which way we look at it. In any case, we can clearly see from the first received header that the sending email is supposed to be mx.openmailsender.fake with a completely nonsensical IP address, but for the purposes of this challenge, this is supposed to be the answer. So we have, after a short analysis of the headers, the answer to the first question. The second one was, what was the original extension of the invoice.doc file? Well, we can clearly see from the text of the email that the invoice.doc is encrypted. So we probably won't discover much by analyzing it as is, but it will probably be some sort of Word document, either an old Word file, and we might also take a look at whether it might be a new version of Word document. How may we do this? We could try to remove the encryption by the use of some specialized tool, but I would like to show you the main or the most straightforward approach to most of these challenges. So the most straightforward in this instance would be to just open the file and then remove the encryption, the password protection, and then saving it again. And we can see that Word itself actually recommends that we save the file as docam. So we can clearly see from both the extension as well as the security warning here that this is a new Word document, which itself is basically a zip file which contains macros. So in answer to the second challenge, or to the second question, the original extension of the attached file was most certainly docam. And we can move on to the first stage analysis. So we have some macros which will probably be malicious from what we can see here. As I've said, I want to show you the most straightforward type of analysis. So in this instance, we can probably or most certainly discover all of this doing static analysis or dynamic analysis. We will mostly do dynamic analysis because it will be more straightforward. I will, since I'm running this file in a sandbox, I will enable the macros to run. We see that nothing seemingly happened. So let's open the VBA editor and take a look at what was supposed to happen. We have the document open sub, which is probably the most common sub used by malicious actors, or usually has been the most common one used by malicious actors. So let's take a look at what we have here. This one will fire on opening a document if macros are enabled. So in this case, this was the code that actually ran. We have some definitions of variables. We have some settings of variables. We have some mathematical operations with variables here as well. And here we have two variables which are set using calls to other procedures, other subs. If we just take a look at what these might be, get A, get B, get C, we can clearly see that all these procedures actually do is set up some sort of string as a return value. So in the end, all of these calls will just set a string, or most likely set a string inside these variables. Then we have several checks. Based on their results, some of the variables will be set to something else, and sometimes some other procedures are called. So what might we do at this instance? We might either go through all of the calculations statically on our own, but to be honest, I don't want to do that, and I wrote this piece of code. It would be a long and not very pleasant effort. Why should we do something that the automation will actually do for us by default? So we can just let the code run and tell it when it should stop. So before we get here, no other procedures are called. So let's try to take a look at what happens if we run this code and it stops here. Now, in terms of debugging in the Microsoft VBA editor, which is part of Office, we have several different options. We have the usual step into by pressing F8. We have step over, Shift F8, and step out, Control Shift F8. So I will mainly be pressing F8, and let's see where we stop. If alpha is 1122, so is alpha 1122? No, it is not, so we will jump over this one. We know that alpha is 1122, still it hasn't changed, so this one won't be called either. Is gamma 4422? It is. So this one will actually be called, and S1 SLA or SLSLA, I'm not sure which one it is, will change accordingly. So in this case, I won't press F8 because we would get to, or we would be sent to get E, get K, and so on and so forth. I will press Shift F8 to step over. Once again, now F8. If delta is 5647, it is. So once again, we will set something into this variable. In Sysla, we have something completely new. We can see that it looks like a URL. So that might be interesting. In this instance, once again, Shift F8. And now we will have a call to this function or this procedure here. In the L0PET variable, we have another URL. So we have two URLs, one in this variable, one in this variable, and both of these variables are actually being passed to this procedure here. So let's take a look at where this goes. I will put another breakpoint here in case we need to restart. So it will create some object based upon these additional calls to some procedures which just give us some strings back. So in this instance, I want to actually see what the strings which will be returned by calls to these procedures actually are. So I will press F8 once again. In this instance, it will return Mike, then another one roso, the other one ft.xm. This one will give us LHTTP, so Microsoft.xml HTTP. All right, so the object is Microsoft.xml HTTP, so probably something which enables the Visual Basic for applications to interact with HTTP server. In this instance, this object is then used to open something. Let's take a look at what. Get. All right, so it will call a get with the second passed variable. So with this URL, it will then be sent. Then we have the response text, which is something which we got from the server. God knows what it is. It's too large to be displayed here. Then it will use the same process to open the second URL. Yes, again, once again with get. And it will pass the second response text and the first response text to another procedure called R0ISDA3. So let's take a look at what this one does. I will once again put a breakpoint here in case we need to restart. In this instance, we can clearly see that it once again defines an object, although in this case it will be something a little bit different. It's not obfuscated. It will create scripting.filesystem object, and it will use this to create a text file, which once again uses something obfuscated. So let's take a look at what. So file out will be this created object, which will be in a path temp, yeah, I can see where this is going, .ps1. So environ calls or basically translates an environment variable. Environment variable temp will be the path to temporary directory / temp.ps1 as we saw. And it will write to this file the first and second payload or the response we got from those two URLs. Now, if we jump back out, the last thing which is being called is this procedure, kfit right here. And this one actually doesn't do anything that surprising. It only, if I see it correctly, takes this file and runs it. So yeah, it will run it using PowerShell no less. So here we get to it calling PowerShell.exe no logo execution policy bypass, so it won't display to us as the user. Once again, it calls the temp ps1, creates this object, and uses wscript shell to execute it. And we end the execution. So why did I show you all of this? Actually, since we don't, strictly speaking, need to analyze all of this. Basically to answer the last question. So let's take a look at what we have here. Go from the first one. From what URL is the next ECSC payload downloaded by the code in the attached file? We've seen this, so let's actually jump straight here. Because if we remember, this is the first URL, this is the second URL. So first one is x90.cz/misc/01292.ooob, and the second one is the same /01292.vm2. So these are the two URLs we are interested in. Where is the next payload downloaded to by the code in the attached file? Well, to the temporary directory as temp.ps1. We can see this clearly if we go to temp, and we should see temp.ps1. As you can see, it's there, so clearly we got this one right. We can actually open it in Notepad++, and we can see that yes, this file has a header of being part of the European Cybersecurity Challenge 2021, which I put there. So what was the last question which forced us to actually analyze the entire code? The question is, does the code in the attached file delete any files from local file system? If so, which ones? No, it doesn't. We went through the entire execution of the macro and it didn't delete anything. So we're done with this part and we can move on to the second stage, or to the second stage's payload. So let's take a look at what we can see from it right now. We know that it was actually executed using PowerShell, so the answer to the first question is fairly straightforward. Which programming scripting language or framework was the second payload written in? Well, obviously PowerShell. We can take a closer look at it if we are uncertain, but in this case it's really PowerShell. So from what URLs is the next, i.e. third payload downloaded by code in the second payload? So once again, we have one or more URLs from which this code will download a payload. In this instance, as in the first one, the most straightforward, or probably the most straightforward way to discover this would again be to let the code deobfuscate itself. Because as we can see, the code is once again obfuscated. In this case, it's a little bit of a different technique, but it's still obfuscated. So what can we do to get rid of this obfuscation? We can once again let the code run itself and deobfuscate itself. How will we do that? Well, it's actually quite easy. We can see from the beginning that the code only sets some variables. And the first time any actual code that is supposed to do something is called would be this part, line 35, where it's trying to download something. I'm not sure what, but it's supposed to download something. So let's take the code that precedes it. Let's open Powershell. And I will input the code up until that point. And right now, the simplest way to discover what's being downloaded would actually be for me to copy the inside part of this download command. And we can see that the URL that's downloaded here is https untrustednetwork.net/files/2021/ECSC/payload.dat. So we know the URL and it's being downloaded. Is it the only one? It, at least for now, appears so, because here we have something that looks like DNS name resolution. And I'm not sure if this is another part of the payload. Well, we'll get to that in a second, but for now, this is the URL which we are sure the payload, or at least its part, is downloaded from. So what key is used to decrypt the third payload? Well, if we take a look at where an encryption, or rather where a decryption might be, it's fairly obvious in this instance. Usually, if you want to find encryption or decryption routines or algorithms, look for loops, because most encryption is based upon looping through some algorithm with some key. In this instance, we have a nice loop here, and we have XOR inside of it. We can see that this variable, which is actually our downloaded file, is being first base 64 decoded right here, and then is being XORed with this variable. So what's the second variable? It's this one, which is actually the DNS name which is being resolved. So I will let this code run as well, let it download the file, and we can move on and let it do this as well. And now we can take a look at what this one actually is. And we can see that it resolved some name, hacking.academy, of this type, txt, and it will take this property from it, strings. So it will try to get a basically DNS response to asking for the domain Hacking Academy with the type txt, which is actually the answer to the 9th question. How is the key downloaded? In this instance, it will be DNS protocol, domain Hacking Academy, hacking.academy, and the type of request is txt. But what's the key itself? Well, if we take a look at what's then being done, it does these two things. So let's see where this gets us. Oh. And we can see, Yeah, so this is probably the string which will be used for the decryption. If I want to be sure, I will put the code once again into PowerShell, let it deobfuscate itself, ask for this variable. Yes, we can see that this will actually be the key, because this is the variable which is being used inside our XOR loop, or inside our loop, decryption loop, to basically be XORed with the downloaded file. So I will let this one run through as well. It should now be decrypted. And then it tries to write all bytes to somewhere. We can see, yeah, these are all the decoded bytes. It will write them using this variable. So let's take a look at what this is. C users user a data roaming Microsoft Windows start menu programs startup. So it will write this as a file login.scr into the startup folder of the Windows. I honestly don't mind that much, so let's let it do exactly this, because it will prepare the file for ourselves. Let's take a look at what this is, hacking.academy. I'm not sure what this is doing here. I might have just copied it there myself during the analysis. In any case, this doesn't do anything, so we don't need to care about it. But now we know that in this path, we actually have our payload. So we know the key. The key was actually, yeah, this variable, this variable. So this is the key that's being used to decrypt the file. And we know that the file itself is in this path, which I believe was another question. Yeah, where is the third payload downloaded to? So we know where it is. We can actually take a look. Yeah, we can see that login.scr is here. And if we should open it in anything, we can see that it starts with MZ, so the usual PE header. So it will probably be just a renamed exe file, but let's not get ahead of ourselves. And let's take a look at the third stage of the malware payload that we have here. So the 11th question overall, first for the third payload, is actually using which programming scripting language or framework was this third payload written. There are many ways to discover this. I will show you one of the tools which one might use to discover this. It's called poetically DIE. It's actually an acronym from Detect It Easy. We only need to drag and drop the file there, and we can see that it was written in one of the .NET languages. It's exe64 or PE plus 64, so it is 64-bit execution. And we can see that it was written in C# if we play around with the tool a little. So it was written in C# and the code is written for 64-bit platform. Another question is, what's the SHA or SHA-1 hash of this payload? There are many tools which we might use in order to discover this. I quite like, for the initial analysis, a tool called PE Studio. And this is another drag and drop utility into which you just have to drop your file, and you will get, amongst many other things, your SHA-1 or SHA-1 hash. We might also just click on it and try to discover whether it's been somewhere. It doesn't appear to have been, but if we take a look at VirusTotal, yeah, it will tell us that it's actually been, probably given the date, uploaded by one of the people who are testing this challenge before the ECSC itself. And it's being detected by 7 anti-malware solutions currently. So we're on the right track, certainly. We now have the SHA or SHA-1 hash. So what was the original name of the file when it was created? Once again, this is something that the PE Studio is able to tell us. If we click just here on the version option, it will tell us that the original file name was scv host, not svc host, but scv host. So 2 letters were actually switched if we are talking about the usual Windows executable. So what was the username of the user who created the original file with the payload? Now this one is a bit more complex, but since I know that it was written in C#, I believe that it was compiled using Visual Studio. If the debug strings were left in place, then we should be able to discover this if we look at strings which are embedded inside the file. Because, and we can see it here, the path to the PDB is embedded in the executable. So in this instance, the user's name, or the user account name at least, was Pavel.Vomacka. So in this instance, someone called Pavel Vomacka was potentially the author of this malware. What path, UNC URL, does the payload use to download commands from the C2 server? So in this instance, we're probably talking about some sort of backdoor or bot which is communicating with C2 server. And the other 2 questions are: what is the period for the contact of C2 server, and what command is used to specify that the payload should not perform any action? Well, these 2 we could actually answer using dynamic analysis. But for the third one, we will probably need to take a look at the code. And since analyzing .NET, if it's not heavily obfuscated, is quite straightforward, we will try to answer all 3 questions using this technique. You could use many different decompilers for .NET. In this instance, we will use dnspy, or rather we will use its 64-bit version, since this is a 64-bit executable. So I will once again drag and drop it here. And let's take a look at what we have there. It seems that it was a forms application. In this instance, not the first thing that is necessarily important, but if the authors of the malware didn't do anything special, the first thing which will run would be the form load. So in this instance, we can see that it will just call what's named getMSFT, and then it will enable timer. GetMSFT will create an HTTP request for Microsoft.com. It doesn't do anything else. If we go back, we can see that all it does is enable the timer. So let's take a look at what the timer itself does. And this looks interesting. Each time the timer ticks, it will create a web request for this URL. That's quite an interesting one. So x90.cz/files/2021/ECSC/C2. It will get the response, and it will then take this response and actually run it using cmd.exe/c plus this code, or this text that it's received from the server. So it's very easy. if it gets any valid command for a command line, it will just pass it to the command line. It doesn't do so if it gets the response wait. So the waiting command, which was one of the questions, yeah, this one. What command is used to specify that the payload should not perform any actions? So obviously wait. We now know the path. It's this URL. The only thing we still don't know is the period for contact of the C2 server. Wasn't it here? No, it doesn't appear to have been. Does the Microsoft set it? No. So in this instance, we might take a look at an initialize component inside the form 1, where the timer itself should be initialized, and we can see that it is. And its interval is set to 60,000. So 60 seconds in real world. So the period is 60 seconds, and we know that the URL is this one. If we wanted to see what command is actually being run by the malware or being executed through the C2, we can take a look, and we see that currently the malicious actor is trying to run ping against 8.8.8.8 or the Google main DNS server. So that would be all. We've analyzed the entire malware from beginning to end. We've seen 3 steps of its payloads. We've seen the original malware laced document, Office document. We've seen the PowerShell stage, and then we've seen the .NET stage. We know how it persists in the operating system, since it actually downloads the exe file into the startup folder. We also know how it communicates, where it downloads its different stages from, what the C2 URL is. So we would be in a very good place if it came to reporting on analysis of this malware. In any case, this was the solution, or rather one of the solutions, for one of the final challenges of ECSC 2021. I hope you've enjoyed it.